Hey guys, tonight we're going to do something very simple and very strange at the same time. We're going to lie here, not moving much at all, and quietly peel back the sky above your head like it's a curtain. Not to make things louder or more complicated, but to see how incredibly weird and beautiful it already is, just as it is right now while you're listening. Maybe you're in bed with the lights low. Maybe you've got a tiny lamp still on. Maybe it's already completely dark and your phone is the only little rectangle of light in the room. Wherever you are, just let yourself imagine a clear night sky above you. Even if in real life it's cloudy or smoggy, or you're in a city where the brightest stars are usually billboards. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like sharing, drop a comment with where you are in the world and what time it is for you right now. I love seeing that little map in my head fill up with people listening from all over the planet, each in their own tiny corner under the same big universe. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Just breathe for a moment. Slow in through the nose if that feels okay, then out through the mouth without forcing anything. Your body doesn't need you to manage it like a micromanager boss. It knows how to breathe perfectly well on its own. You're just here to notice. Feel the weight of the blanket, the way the mattress holds you, how your shoulders can drop just a little bit more than they were a second ago. Let your jaw unclench. Your phone or screen is doing the work now. You don't have to. Now, in your mind, lift your gaze. Imagine the ceiling slowly becoming transparent, like glass dissolving into nothing, until there's just you, and above you, that huge, deep, dark space. Stars scattered across it. Maybe a soft band of the Milky Way like a spilled trail of sugar. It looks like a picture, something flat and decorative, like wallpaper stretched across infinity. But tonight, I want you to think of it very differently. Not as a flat ceiling full of dots, but as a layered story of time. Because what you're looking at, what your mind is projecting up there, isn't just distance. It's history. Every point of light is not just somewhere, it's somewhen. The sky is basically the universe's most dramatic "this is what I looked like ages ago" selfie. When you look at it, you're not seeing the universe as it is. You're seeing the universe as it was. Take the moon for a cozy starting point. If you step outside on a real night and look up at the moon, the light that hits your eyes left that surface just over 1 second ago. Not very impressive, right? It's like getting a text with a 1-second delay. No big deal. But even there, technically, you never see the moon now. You always see the moon slightly in the past. Move a little further out. The sun. Please don't actually stare at the sun. I feel like I shouldn't have to say that, but just in case. The sunlight that warms your skin in the day has been traveling for about 8 minutes. If, very dramatically, the sun disappeared this instant, Earth wouldn't know for 8 whole minutes. The sky would stay bright, birds would keep flying, traffic would keep honking, and we'd all be blissfully unaware that the central star had rage quit the solar system. That's how hard reality commits to the bit of nothing moves faster than light. Now stretch that feeling out. The nearest stars beyond the sun are years away in terms of light travel. When you look at them, you're seeing light that left before your last birthday, or your last relationship, or high school, or whatever big milestone is floating around in your mind right now. Some of the stars you see are sending you light that started its journey before your grandparents were born. A few of them are sending you light that set off before humans even knew galaxies were a thing and not just tiny smudges we don't understand. And as you imagine going deeper and deeper out, those delays get stranger. Millions of years, hundreds of millions, billions. When you picture a distant galaxy, one of those gorgeous spirals you see in space photos, you're not seeing how it is now. You're seeing a frozen frame from long, long ago. It's like the universe's version of old family photos in a box, except the box is 40 billion light years wide, and we're lying underneath it in sweatpants. The really wild part is that there's a limit to how far those cosmic photos can reach us. Not because the universe ends out there with some kind of brick wall, like a video game map where you suddenly hit an invisible force field. It's much simpler and somehow more dramatic than that. There's only been so much time since everything began. Light travels at a fixed speed. Time is finite. Put those together, and you get a horizon, not a visible one. You won't see a line across the sky where light just stops. It's more like a quiet rule in the background that says, okay, from this radius outward, nothing has had time to send you a message yet. The sphere defined by that radius is what we call the observable universe. It's centered on you, on this exact point in space where you're lying, and it stretches out in every direction to the farthest places light has had time to reach you from since the beginning. Beyond that, things might be there. They probably are. But their light is still on the way, and for a lot of them, it will never make it here. Just let that sit with you for a moment. You're a cocoon not just in a room or a building or a city, but inside your own personal bubble of visibility. A sphere made not of glass or walls, but of time. Everything you can possibly see in principle, even with the fanciest imaginable telescope, sits inside that bubble. Everything outside of it is, for you, permanently offstage. Still part of the play, maybe, but never stepping into your spotlight. The comforting bit is that everyone has their own bubble. If there's a person right now dozing off on some exoplanet halfway across the cosmos, listening to their own cozy sleep science podcast in whatever language they use, their observable universe is a different sphere centered on them. Some parts overlap with ours. Some parts don't. Their night sky has its own pattern of stars, its own farthest lights. So even the idea of the observable universe isn't a single rigid thing. It's personal, like a cosmic aura defined by where you are and when you are. The reason this matters, and the reason I'm walking you gently through it instead of just whispering it's big out there, wow, is that this horizon of light is the key to everything we're going to explore tonight. Because once you understand that the sky is a time-layered sphere of messages and that there's a boundary beyond which nothing has reached you, the next questions start to feel more natural. What lies beyond that boundary? Does space keep going? Does it curve back on itself? Are there regions we'll never see that still tug on the edges of our imagination? For now, though, keep it simple. Picture your observable universe as a kind of soft, glowing bubble around you, about 90-something billion light years across, expanding as more light arrives, but at the same time kind of limited by how fast that light can move and how the fabric it travels through behaves. You don't have to remember the numbers. Your brain is already full of more important things, like song lyrics you never chose to memorize. Just remember the feeling. There is a horizon, and it is made of time. If you let your attention drift over one star in that imagined sky, maybe a bright one just above you, you can almost picture the beam of light coming down like a thread. That thread is a timeline from that star's past to your present. Now, imagine millions of those threads, all different lengths, all coming from different moments in history, all arriving at your eyes tonight. The sky turns from a flat ceiling into a tangled, shining web of time. Every direction is a different past. Every dot is a different years ago. And here you are, at the center of it, not in an egocentric way. We're not crowning you ruler of the universe, don't worry, but in a very literal geometric way. You're the point where all those light paths finish. Your room, your bed, your tired brain, they're the final stop for light that has been traveling calmly, steadily, for so long you don't even have a word that feels big enough for it. There's something really grounding in that, strangely enough. The day you just had might feel messy, your thoughts might be loud, the world might feel chaotic, but above all of that, the universe is sending you light that left before any of your problems existed. It doesn't hurry. It doesn't rush to comfort you. It just keeps arriving at exactly the speed it always has, like a cosmic reminder that you're a part of a much bigger timeline than whatever happened on your phone today. As your shoulders sink a little deeper into the mattress and your breathing finds its own slow rhythm, you can let that bigger picture hold you. The room is small. The planet is small. Even the observable universe is just a bubble inside something larger we haven't fully grasped. But right now, that bubble is more than enough. Inside it are galaxies, clusters, a cosmic web of matter, and all of it is sending out light, some of which is reaching you tonight quietly, one photon at a time. We'll follow those photons outward in a moment. We'll look more closely at how they turn distance into time and how, together, they draw the line between what you can know and what forever will keep to itself. For now, just stay here, under that imagined clear sky, and let the idea sink in. Every star you've ever seen, every galaxy in every picture, every faint glow in the background, all of it is part of your horizon. Not an edge of existence, just the current edge of your awareness. And beyond that edge, the universe keeps going patiently, whether you're awake to think about it or already drifting off into your own private darkness. You're still lying there beneath that imagined sky, the ceiling fully gone now, replaced by a dome of quiet darkness and scattered stars. And the thought we ended on, this idea of everything you see being a message from the past, starts to stretch itself out like a cat settling into a warm spot. It's not a complicated idea. In fact, it's almost too simple. Light takes time to travel. You see things as they were. But when you let that settle for a moment, when you slow it down and let it sink deeper, it becomes one of the most quietly astonishing facts you'll ever carry around in your head. Because light isn't just illumination. It's not just brightness. It's not just the thing that lets you see your hand so you don't knock over your water bottle at 3 a.m. Light is the universe's way of reporting its own history to you. It is the most patient storyteller you will ever know. It doesn't speak in sentences or paragraphs, at least not in the way your brain normally thinks of communication. But every photon, every tiny packet of light, is essentially a timestamp from whatever it left behind. Imagine holding a little envelope between your fingers. Inside, there's a note that says, "Hey, I left this star 57 years ago." That's what a photon is without the envelope or the handwriting or the stamp. It's a messenger that never changes speed, never gets tired, never stops halfway to grab a coffee. It sails through space with this serene determination, carrying the imprint of its birthplace and the moment it departed. When that light reaches your eye, or the lens of a telescope, or the sensor of some fancy observatory on a mountaintop, it completes a journey it has been committed to for years, centuries, millions of years, sometimes billions. It doesn't know you're here. It doesn't know anything at all, obviously. But in completing that journey, it hands you information from a place so far away and a moment so long ago that you could walk your whole life and never truly feel the scale of it in your bones. So lie here with that sky still hovering above you and imagine that every flicker, every glint, every faint glow is a message arriving exactly when physics says it should. No delays, no shortcuts, no express delivery, just the speed of light, always the same, always steady, always the limit that everything else has to respect. The moment you understand this, really understand it, the night sky changes character. It stops looking like scenery and starts looking like memory. A single photograph stretched around you in all directions, taken from countless angles and countless moments, stitched together into one enormous spherical scrapbook of cosmic history. Take a breath and let your mind wander to one particular star up there. Pick any one. Imagine yourself reaching out to it with your thoughts, like you're touching its light. What you're touching is the past. Not your past, though it overlaps with you now, but the past of that star. You're not seeing how it looks tonight. You are seeing the version of it that existed when the light left. Maybe that was 50 years ago. Maybe it was 500. Maybe that star doesn't even exist anymore. Maybe it blew apart in a supernova before smartphones existed, but the light from its quiet pre-explosion life is still traveling toward you, unaware of the drama that came after. There's something soothing in that. Light doesn't rush. It doesn't panic when things happen. The star could explode, collapse, transform, and the light that left before any of that will still take its calm, steady trip through space until it reaches you. The universe doesn't edit or censor its past. It sends you everything it already released, one photon at a time. Now imagine zooming outward in your mind, faster than any rocket, but still riding on the idea of light itself. Imagine leaving Earth so quickly that the moon slips behind you, then the sun shrinks, and suddenly you're drifting among the nearby stars. Each one sends out light like ripples on a dark pond, expanding in perfect spheres, touching everything in their path. Some of those ripples started long before humanity existed. Some began during the rise of dinosaurs. Some left their stars when the first mammals were just tiny, nervous little creatures hiding in bushes. And they've been traveling uninterrupted ever since. If you keep going, moving out past the nearest stars to the wider neighborhoods of our galaxy, the light you encounter grows older. The messages it carries are older, more distant, more ancient. And the farther out you go, the more you realize that our place in all this isn't just small, it's deeply delayed. We are the late recipients of a very long-running broadcast. You know those old TV antennas people used to have in the 90s, where the signal would occasionally glitch and you'd see half a second of something that had happened earlier? That's the universe, except instead of dropping a millisecond of audio, it stretches out time into billions of years and sends you the whole recording anyway, perfectly intact. But there's a twist hiding in all this, and it changes everything. Light might be constant in speed, but space, the thing it travels through, is not constant at all. It stretches, it expands, it grows, which means the path light takes isn't a simple straight line like a little photon road. It's like trying to run across a hallway while someone slowly moves the walls farther apart. Light keeps traveling, but the destination keeps stretching away. This is where the universe starts getting beautifully, deliciously weird. Because light doesn't just carry information about the past. It reveals how space has changed since the moment the light began its trip. The farther the light traveled, the more stretched it becomes. Literally stretched. The wavelength grows longer, the color reddens, like taking a picture and pulling it gently until the whole thing loses some sharpness. We call that redshift, but you don't have to memorize the word. Just think of it as the universe subtly tugging at every cosmic message the longer it travels. So when you look at a galaxy far away, you're seeing not just what it looked like billions of years ago. You're seeing the imprint of how space has behaved during those billions of years. Light is like a reporter that not only tells you what happened at the moment it left, but also scribbles notes about the journey along the way. By the way, space got a little bigger while I was traveling. It says, "Here's how stretched I am now," so you can figure out how fast the expansion was. And scientists do figure it out. They look at how much the light has been stretched, how long the journey must have taken, and they piece together a picture of how fast the universe has expanded over time. In that sense, light isn't just a messenger. It's also a measuring tape, a cosmic ruler, a logbook, a historian. All of that from tiny particles that don't even have mass. This is the beauty of letting yourself think slowly about the night sky. You start to uncover layers of meaning in something you've probably seen 1,000 times without thinking twice. The universe isn't throwing information at you like a teacher waving a textbook. It's whispering, quietly, patiently. You just have to listen in the right way. The more you listen, the more the horizon we talked about earlier starts to feel less like a boundary and more like an invitation. A soft edge saying, here's what has arrived so far. Everything beyond this, it's on its way, or maybe the universe itself is expanding too fast for it ever to reach you. There's something both comforting and haunting about that. The sky is full of messages still en route. Light that set off billions of years ago, but will never arrive because the space between us and the source is stretching faster than light can cross it. That isn't failure. That isn't loss. That's just the physics of a universe that's always moving, always expanding, always changing the rules slightly. And yet, despite all that motion, some of the oldest messages, some of the most ancient photons in existence have already reached us, and they carry stories from times so early, so primordial, so raw that they make everything else seem like an afterthought. We're going to go to those oldest messages soon, the first light ever released. But for this moment, just let this idea settle again. Every star you see is a memory. Every breeze of brightness is a timestamp. Every photon touching your mind tonight has been traveling longer than almost everything you know. And somehow, through nothing but the stubborn consistency of physics, it found its way to you. Stay right where you are for a moment, still beneath that quiet imaginary sky, still feeling the weight of the blankets and the soft rhythm of your breathing. Because now that you understand that every point of light above you is a message from the past, we can finally talk about the stage those messages travel across. And this part, the part you're about to step into, is where the universe starts showing its wild personality. This is where space itself stops being a background and starts acting like a character with its own stubborn opinions about how big it should be. Let's start gently. Think about a normal road for a moment. A real one. Asphalt. Lines painted down the middle. A road you could walk down if you weren't lying here in bed pretending to stare through a transparent ceiling. If you walk away from your house, the road stays the same size beneath your feet. It doesn't stretch just because you decided to go get snacks. It stays still, solid, predictable. Space is nothing like that. Space is not a still surface. Space is not a quiet, neutral canvas. Space is more like a slow, gentle balloon that never stops inflating. But, and here's the tricky part, it doesn't inflate from a center. It doesn't expand outward like a sphere. It expands everywhere, all at once, in every direction. There's no middle. There's no edge. There's no starting point that you can label like, here, this was the corner it began from. Space behaves more like rising dough. Not that I'm trying to ruin bread for you, but it's the same kind of all-over expansion. Every part of the dough pushes away from every other part as it grows. Now imagine light trying to travel across that dough. Imagine the photon we talked about earlier, the tiny messenger carrying the timestamp of some distant star, trying to walk across this stretching surface. At first, the distance is manageable. The star releases it, and it heads toward you like a little marathon runner. It's going fast, faster than anything else in the universe ever gets to go. But the road beneath it, the very fabric of space, is quietly lengthening as it moves. Picture the photon running toward you, legs pumping. Okay, no legs, but go with me. And the finish line keeps sliding away, pulled gently by the stretching of the universe. That is the reality of light traveling through space. It doesn't drift across a static void. It travels across a fabric that is actively expanding beneath it. You could be the world's fastest sprinter and still not win a race if the track keeps growing at the same time. In most places, light still wins. It's fast enough, determined enough, unstoppable in its own tiny particle way. But when the expansion is strong, when space itself stretches faster than the photon can close the gap, the light falls behind. It never arrives. It becomes a message that was written, sealed, sent, and then lost in the shifting corridors of reality. But don't worry, we're not losing messages from everything. We're still receiving light from billions of galaxies, billions of years into the past. The stretch of space is gentle enough on human scales that you don't feel it. Your body doesn't expand. Your furniture doesn't drift away from you at night. The room doesn't quietly swell by a centimeter while you blink. The expansion only becomes noticeable across vast, intergalactic distances. So picture yourself out there in that cosmic ocean. Not moving physically, just imagining. Imagine drifting far from Earth, far from the Milky Way, until you can see the shape of cosmic expansion happening beneath you. You wouldn't see galaxies flinging themselves apart like debris from an explosion. They're not zooming through empty space like shrapnel. The galaxies mostly sit where they are, anchored by gravity, bound into clusters, swirling around each other. What's really happening is that space between those clusters grows. Think of it like dots on a balloon. When you inflate the balloon, The dots don't move. The surface between them stretches. That's why, in the real universe, galaxies far from us seem to be moving away even though they're not flying through space like cartoon rockets. They're just sitting on the stretching surface. And here's where things get a little uncanny. The farther away a galaxy is, the faster it seems to be moving. Not because it's actually going faster, but because there's more space between you and that galaxy, and all of that space is expanding. Each little piece of space adds a tiny bit of stretching. Stack enough tiny stretches together across billions of light years, and you get enormous apparent speeds. Eventually, some galaxies are so far that the expansion of space between you and them makes them appear to recede faster than light itself. This isn't breaking any rules, by the way. Nothing is moving through space faster than light. Space is just expanding underneath everything, and light doesn't get any special discount. It still has to cross the expanding road. Now, back in your imagined sky, pick one of the faintest smudges you can see. A tiny galaxy, something barely noticeable. The light from that smudge left long before Earth even existed. It began its trip when the universe was young. The space between that smudge and you has grown and grown the entire time the light has been heading your way. Some of that light will barely make it. Some won't. And some galaxies like that are already beyond the reach of light entirely. Even photons emitted today will never arrive here. But the ones you can see, that's the miracle of this section. Every faint glimmer, every soft glow, every blur in the background is a victory. It's light outrunning or outlasting the expansion of space itself long enough to reach you. Think about that the next time someone posts a beautiful space photo from a telescope. It's not just a picture. It's a cosmic endurance story. Now, stay with the image of that expanding road. Let it stretch beneath the night sky. Imagine yourself gently floating above it, feeling how the distance grows so quietly you'd never notice unless you measured it over billions of years. And then think about the flip side. Because space has been expanding the whole time, the light that reaches us didn't travel through the same sized universe the whole way. It left a much smaller universe. A universe packed tighter. A universe with galaxies huddled closer. Space has grown enormously since many of the photons you see tonight first set off. This means something strange and subtle. When we talk about how far away a galaxy is, we're talking about two distances at once. First, there's how long its light has traveled, the look-back time, which tells you how old the light is. Second, there's how far away the galaxy is now, after billions of years of expansion. Those two numbers can be wildly different. You can receive light that traveled, say, 13 billion years from a galaxy that now sits over 30 billion light years away, because the universe expanded during the light's journey. This is part of why your observable universe is not simply the diameter of a universe so far. It's a dance between light's travel time and the stretching of the fabric it moves through. And here you are, lying in bed, casually listening to this cosmic choreography like it's a bedtime story. The expansion has been happening the entire time your planet has existed, the entire time your species has existed, the entire time your life has unfolded. But it's so slow on local scales that you will never feel the stretch personally. Galaxies feel it, but you don't. Clusters of galaxies feel it, but you don't. Every distant light in the sky feels it, but your cup of water is safe where it is. That contrast, the stillness of your bedroom and the expansion of everything outside it, is what makes this moment so peaceful. You're lying in a universe that is constantly growing, constantly reshaping itself, constantly lengthening the invisible roads between its most distant points. And yet nothing around you is disturbed. You're held gently in a tiny gravitational bubble, protected from the swelling of cosmic space by the local glue that binds matter together. It's almost funny in a whispered, sleepy way. The universe is stretching itself into something unimaginably large while simultaneously letting you rest without feeling a thing. And as your breathing slows and the sky above you seems to deepen, You can start to imagine what comes next. What happens when those expanding roads create horizons that move away from us, not just in space, but in time. Horizons that tell us what we can know today, what we might learn tomorrow, and what we will never, ever receive a message from. That's where we're heading next. To the shifting edge of visibility. To the boundary that isn't a wall, but a moving limit. A cosmic fact written not in stone, but in the speed of light and the stretch of space. Stay with that sky for now. Let it hang above you like a quiet dome, soft and endless. The stars scattered across it like they've always been there, just waiting for you to lie down and notice them. You already know that the light reaching you is ancient, and that the space it travels through is constantly stretching. But tonight we're going deeper, into the idea of the horizon itself, the shifting boundary that marks the farthest places from which the universe has successfully delivered its messages to you. This horizon is not a physical edge. There's no surface out there where the universe suddenly stops. You won't crash into anything if you crossed it. In fact, if you somehow found a way to teleport to the very edge of what you can currently observe, the universe around you would stretch out in every direction exactly like it does here. No thinning, no fading, no sign that you're standing on the brink. The observable horizon is simply the farthest distance light has managed to travel since the beginning of time. But here's the twist, and it's a subtle, beautiful twist. This horizon doesn't stay still. It grows. Every moment you're alive. Photons that were once too far to reach, you've finally finished their ancient journey and slip quietly into your part of the cosmos. Your observable bubble expands as more light arrives. New stars, new galaxies, new stretches of cosmic landscape gradually reveal themselves. Not because you move, but because their old messages have finally caught up. Imagine that. You're lying here, breathing slowly, body still, mind quiet, and the universe is quietly growing inside your awareness. The horizon is pushing outward as though the universe is gently rolling back a curtain, letting you see a little more, and a little more, and a little more. It sounds poetic, and it is, but it's also physics. The universe is 13.8 billion years old, but because space has stretched so much since the beginning, the radius of your observable universe is around 46 billion light years. That's the distance from you to the farthest place whose light has just now arrived. Everything beyond that is still trying to reach you. Or rather, some of it is trying, some of it will never make it, but we'll get there soon. For now, picture this. You are the still point at the center of an expanding sphere of visibility. Not because you're special, not because the universe cares where you're located, but because everywhere is the center of its own observable universe. Space doesn't privilege any direction or location. It just lets time draw a boundary around light. So imagine floating inside that invisible bubble, but now imagine it moving. It's not a static snow globe. It's more like a living organism, like a slow-growing shell around you. The outside edge, the boundary where the farthest light is only now touching your sphere, is always creeping outward because more time means more distance that light was able to cross. It feels comforting, doesn't it? Like the universe is unlocking more and more of itself as the seconds pass. But the comfort doesn't last long, because right behind this hopeful image comes the unsettling, quiet truth. The expansion of space is too fast for some regions ever to send you a message. The horizon grows, yes, but the universe expands more quickly. Imagine standing in the middle of a field while a fog rolls away from you. For a moment, the air clears and you can see a little further. But the field itself is stretching, slipping out from beneath the fog. And no matter how clear the air gets, the edge of the field grows away even faster. That's the cosmos. Some galaxies are emitting light right now, shining with all their strength, and their photons launch toward us like runners. But the space between us and them expands too quickly. The runner never makes it. The finish line keeps accelerating away. And here is the detail that feels almost unfair. Some of those galaxies are ones we can see today. We're not talking about invisible ones. We're talking about visible galaxies whose future light will never reach us. Think about that. There are galaxies in the night sky, right now, tonight, in your imagination overhead, whose light left billions of years ago and managed to outrun the expansion. That ancient light finally made it. It arrived. It hit your eyes, or your telescope, or your imagination. But if those galaxies shine again, if they keep glowing, their newer light is already doomed. It's trapped behind a boundary that stretches faster than any photon can cross. It's like receiving a postcard from someone who has already boarded a train accelerating so quickly that no future messages will ever catch up. So tonight, as you lie here, some of the objects you can see are already gone from your reachable universe. Not destroyed, just moved beyond the horizon. Their future is sealed away by the speed at which space expands. This makes the horizon a bittersweet thing. It's not just the edge of what you can see. It's the edge of what you can ever see. There's a word for that deeper boundary, the cosmic event horizon. It's not the same as the observable universe. It's farther inward. It marks the places whose future light emitted from this moment onward, will never reach Earth. Imagine the sky as a map slowly peeling away from the edges. Not fast, not dramatically, but steadily, silently, like paper curling in slow motion. Galaxies drift from visible to unreachable. They slip quietly into a realm beyond communication, beyond contact. Not because they disappeared, but because their messages, from now on, can't reach you anymore. This horizon, the one that moves away from us faster than light can chase, is one of the most existentially gentle but haunting truths of cosmology. It doesn't warn you with bright colors or danger signs. It doesn't pulse with heat or emit any sound. It's simply a mathematical fact woven into the structure of space-time. So as you breathe slowly and feel your body relax deeper into the bed, imagine this. All around you, stretching outward for billions of light years, the universe is quietly dividing itself into two spheres. One sphere contains everything whose light will reach you eventually, no matter how far away it begins its journey. The other sphere contains everything forever beyond reach. The boundary between them isn't a wall. It's a speed limit, a consequence of expansion. And that boundary is drifting outward like the tide, pulling entire galaxies behind it, one by one. Picture a lighthouse at the shore, sending beams into the night. You stand far away, waiting to see the sweep of light pass over you. But the shoreline itself is stretching away faster than the lighthouse can rotate. The beam never reaches you, not because the lighthouse turned off, but because reality outpaced illumination. That's what's happening on cosmic scales. Galaxies are the lighthouses. Space is the shoreline. Light is the sweeping beam. And you're the watcher lying in bed, receiving a mix of beams that made it and beams that will never come. There's something quietly humbling about recognizing this. The universe is too large, too fast, too dynamic for us ever to see all of it. The horizon is both a promise and a farewell, revealing new regions as older ones slip away. The most poetic part is that this happens independently of your choices. You could build the most powerful telescope ever imagined, and it would still be bound by the horizon. You could wait 1 trillion years, and the horizon would still outrun you. You could gather the entire energy output of a galaxy and try to push a spacecraft faster, and physics would look you calmly in the eyes and say, "Nice try, but no." That isn't sad. Not really. Not tonight. Because the universe isn't teasing us with what we can't see. It isn't hiding anything out of spite. It's just being exactly what it is. Vast, expanding, patient, structured. And the part you can see, the part whose light has already arrived, is more than enough to fill a lifetime of curiosity. This shifting horizon, this moving boundary, is exactly what makes the next part of our journey possible. The first light that ever escaped the fogged-up early universe. A message so ancient, so stretched, so delicate, that it's still arriving right now, washing over your skin and your blankets and the walls of your room as a soft, invisible glow. We're about to step into that glow next. The very first photons. The first cosmic message that ever had the freedom to travel. Keep your breathing soft and easy as you lie there beneath that imagined night sky. Because the moment we're stepping into now is older than any star, older than galaxies, older than almost everything you've ever heard about the universe. It's not just old. It's the oldest light you will ever encounter, the first whisper the cosmos ever released once it had a voice at all. And that whisper is still touching you tonight in its quiet, stretched out way, even if your eyes can't see it. Let's take a slow step back, way back, to a time when the universe wasn't open and clear the way you picture it now. Imagine the early universe not as darkness wrapped around bright stars, but as a glowing fog so dense and hot that light couldn't get more than a few centimeters before being scattered like headlights in a blizzard. The universe was filled with plasma, a hot soup of free electrons and protons, and photons ricocheted off those electrons constantly. Nothing moved in straight lines. Nothing escaped. Light was trapped inside the cosmic fog, bouncing and bouncing and bouncing like a strobe light locked in a smoke-filled room. It was chaotic, loud in the sense of energy, not sound, packed, blinding. The kind of place where light had no chance of carrying a message anywhere, because it couldn't even take a single clean step. And this state lasted for hundreds of thousands of years. In that era, the universe looked nothing like stars and galaxies space. It was closer to the inside of a star, a glowing, shimmering brightness contained within itself. But the universe doesn't stay still. It expands. And as it expands, it cools. Slowly, patiently, like a kettle taken off the stove. The fog didn't vanish all at once. The photons didn't suddenly break free like a jailbreak. Instead, something wonderfully simple happened. Temperature dropped just enough for electrons and protons to slow down and finally combine into neutral atoms. It was like watching a crowded room of people finally settle into chairs. Suddenly things had order. Space became transparent for the first time. Light didn't bounce as wildly anymore because electrons were no longer roaming free. Photons, for the first time in the universe's entire history, could travel in straight lines. Think about that. For the first few 100,000 years after the Big Bang, the universe was silent to observers, if any existed, because light wasn't allowed to escape its foggy prison. And then, in one cosmic moment, the fog cleared and the universe exhaled its first breath of visible light. The photons released in that moment have been traveling ever since. Traveling without obstruction. Traveling across the continually expanding fabric of space. Traveling longer than any star has lived. Traveling longer than Earth has existed. Traveling longer than the Milky Way itself has been a coherent spiral. Tonight, those photons are still arriving. They wash over you as a faint, cold glow. Microwave light so stretched and weakened by expansion that it's far beyond what your eyes can detect. You're bathed in it constantly. Every second, every moment of your life. It fills your room. It fills the space between the atoms in your body. It's everywhere. This glow is called the cosmic microwave background, or CMB, but names don't matter right now. What matters is the feeling of what it truly is. The oldest visible light in the universe, a fossil of illumination, a snapshot of the moment when the universe first became transparent. Let yourself imagine it. Close your mental eyes and picture a soft, reddish-yellow light filling every corner of space. Not a spotlight, not a beam, a background, a warm fog that has been stretched to coldness by billions of years of cosmic expansion. If you could somehow tune your vision to microwave wavelengths, the entire sky would glow evenly, not with stars or galaxies or shapes, but with an almost perfect uniformity. A sheet of ancient light spread across all directions. But almost perfect is key. That glow isn't smooth. If you could magnify it 1,000 times, 1,000,000 times, you would see tiny temperature variations, minuscule bumps and dips in brightness no bigger than a few hundred thousandths of a degree. Those slight imperfections, those tiny wrinkles in the baby universe, are the seeds of everything. The seeds of galaxies, the seeds of clusters, the seeds of cosmic structure, the seeds of you. The photons in this background aren't just old, they're informative. They tell us about density in the early universe, about how matter clumped, about how gravity shaped that clumping. They tell us about the curvature of space, about how fast everything expanded. They reveal ripples that inflation stretched out. They show us clues about dark matter, about the universe's shape, about its fate. It's wild, really, that this quiet glow in your room contains the answers to some of the most profound questions humans have ever asked. But for now, don't think of it as data. Don't think of it as an equation or a graph or something a scientist would present in a lecture with a laser pointer. Think of it like a cosmic lullaby, a background hum that's been playing since long before the first star flickered into being. Imagine lying there under that night sky, and even though you can't see it, there's a soft warmth woven into the darkness, a fingerprint of the universe's earliest memory. It's not loud. It's not urgent. It doesn't need your attention. It just rests around you, a quiet reminder that the universe has been glowing for almost 14 billion years straight. That's the beautiful part. The cosmic microwave background isn't just old. It's continuous. It never stopped traveling. It never stopped arriving. And every single night you've looked at the sky, even on cloudy nights, even through windows, even lying on your back indoors, it's been washing over you, brushing against your skin, passing through you without harm, like a gentle echo of the universe's childhood. Now, picture something stranger. Imagine that moment when the fog cleared, the moment photons were freed. Imagine you're inside the early universe, watching the fog thin. You'd see the glow everywhere, uniform and soft. But as the universe kept expanding, that glow would dim. Its color would shift. Its wavelengths would stretch. It would go from a brilliant brightness to a red glow, then infrared, then microwave. If the universe were older, even older than it is now, that glow would stretch all the way into radio waves and vanish from detection entirely. Which means we live in a very lucky era. We live at a time when the first light is still visible, not to your eyes, but to our instruments. In the far future, as expansion keeps accelerating, that ancient glow will fade out of our reach. Eventually, no civilization, no matter how intelligent or advanced, will be able to detect it. Think about how strange that is. The most important evidence of the early universe, the single greatest clue to our origins, will someday slip away behind the curtain of cosmic expansion forever. But not tonight. Tonight, while you lie here breathing softly beneath that imagined clear sky, you are surrounded by the oldest light in the universe. You are inside a warm memory that has cooled for nearly 14 billion years. You are resting in a glow that predates galaxies, stars, planets, oceans, trees, animals, voices, dreams, everything. It's still here. It's still showing you where the universe came from. It's still whispering its message of beginnings. And now that you understand that whisper, we can go deeper. We can step into the fog itself, into the era before light had any freedom at all. We can explore the moment when the universe was loud and bright and crowded, before photons escaped, before space became transparent, before time took on the meaning we recognize. Because the story of the universe doesn't start with light. It starts with a fog so thick that light had no direction. Keep your mind soft, your shoulders loose, and that quiet sky above you. Because now that you've touched the first light, the soft, ancient glow still drifting across your room, we're going to step backwards into the part of the universe that came before that light, before photons could move freely, before the cosmic fog cleared, before space became the calm, transparent place you're imagining overhead. This is the era when the universe wasn't something you could look through. It wasn't open. It wasn't dark. It wasn't speckled with stars. It was thick, dense, bright. A glowing, crowded, restless ocean of particles constantly smacking into each other like an endless cosmic traffic jam. If you could somehow be dropped into that early universe, not as a body, because nothing shaped like you could possibly survive there, but as a drifting consciousness, you'd be inside something that felt like the center of a star. Not hot like a sunny day. Hot like every atom stripped apart and thrown into a riot. Nothing had form. Nothing had space to breathe. Photons couldn't take a step without bouncing off a free electron. It was the universe's long, energetic inhale. Take a slow breath now. Easy. And imagine a fog so bright that if your eyes existed back then, you wouldn't see anything at all. Not darkness, not shapes, not details. Just pure, overwhelming brightness. Not because the universe was lit with stars. They didn't exist yet, but because everything was hot plasma. Everything glowed. Everything was light and nothing was transparent. It's almost funny in a quiet cosmic way. The universe wasn't born in darkness. It was born blinding. But let's slow down the picture. Imagine hovering inside that era with me, floating weightless. Everywhere you turn, the same glowing fog surrounds you. Turn left, it's the same. Turn right, the same. Look up, the same. Look down, same. There is no direction, no landmarks, no up or out. Just this uniform brightness, thick and soft and violent all at once. Electrons fly freely. Protons drift. Photons ping-pong endlessly like hyperactive fireflies trapped in a mirrored box. If a photon tries to travel, it's immediately scattered. Over and over, billions of times per second, like the universe refusing to let any message escape. Nothing that looks like structure exists yet. No galaxies, no clusters, no stars, not even atoms. Without atoms, there can't be air or water or anything you've ever touched. It's all just raw material, too energized to settle into anything stable. And yet, within that chaos, tiny ripples existed. Gentle variations in density, so small they would have been invisible to any eye. Bumps, dips, wrinkles. Places where there was slightly more matter, slightly less. These tiny imperfections, just a few parts in 100,000, were everything. They were the seeds from which all structure would one day grow. Imagine holding a smooth sheet of cloth. Now imagine barely pinching it in a few random places, making tiny wrinkles. Those wrinkles are what the early universe looked like if you zoomed out far enough. Smooth, uniform, glowing plasma, but with the faintest hints of unevenness. Those tiny fluctuations weren't accidents. The universe was too dense, too hot, too dynamic for perfect uniformity. And deeper still, inflation, the wild expansion that came before this era, had stretched those microscopic quantum wiggles into macroscopic ripples. Inflation took the smallest vibrations of existence and turned them into grand-scale patterns. But in the fog era, you wouldn't see any of that. Everything around you would just feel bright and smooth. The wrinkles would be invisible without math, without time, without cooling. Cooling is the key here. The universe didn't calm down because something happened to space. It calmed because expansion stretched everything apart, letting heat bleed away. Imagine taking a lump of molten metal and slowly letting it cool. At first it's glowing and chaotic. Then the glow fades. Then it solidifies. The early universe followed the same vibe, except it took hundreds of thousands of years, and the metal was literally everything. Little by little, as expansion continued, the temperature dropped. The photons became less aggressive. The electrons slowed down. The protons drifted more lazily. Until finally, one quiet moment, around 380,000 years after the beginning, a threshold was crossed. The fog thinned. Not all at once, like someone flipped a light switch. More like frost melting under a sunrise. Electrons finally had enough peace to latch onto protons. They formed neutral hydrogen atoms, simple, delicate, stable. When they did, the fog cleared because photons no longer had free electrons to ricochet off of. For the first time, light could travel without being pinned down. We talked in the last section about the first light, the cosmic microwave background. But here, inside the fog, you're standing at the moment before its release. You're standing in the last seconds of brightness that would never reach you. Every photon around you is about to either begin its lifelong journey or be scattered one last time before the universe becomes transparent. Picture that transition. One moment the fog is thick and glowing. The next moment, the glow remains, but the fog itself dissolves, turning clear. Suddenly, photons rush outward in every direction like wild birds that have just been freed from a cage. Not with speed, they were always moving at light speed, but with freedom. No more scattering, no more collisions, no more bouncing. Just long, clean flights into the future. Those are the photons that reach you today. But before they escaped, the fog itself was like a cosmic womb, a bright, energetic cradle sustaining the early universe. If your mind wants to translate this into something human, imagine being underwater and seeing sunlight as blurry, chaotic, dancing streaks. Then imagine rising slowly to the surface. The moment your head breaks through, the world becomes sharp, clear, open. Before that, the water carried the light but distorted it. After that, the air lets the light travel freely. That's the visual feeling of the fog clearing. Except instead of happening over a couple of seconds like a swimmer breaking the surface, it happened across the entire universe in a wave of cooling and recombination. And here's the part that always gives people a little gasp if they let it sink in. The universe you live in was once completely filled with visible light. Not stars, not galaxies, just pure, glowing brightness. And now, billions of years later, that same light has been stretched by expansion into gentle microwaves that wash over you every moment of your life. You are living inside the faded echo of the universe's first visible glow. Everywhere you go, you carry that glow with you. Not metaphorically, but physically. The photons are literally everywhere around you, passing through everything with ease. Your room, your blanket, your skin, they're all bathed in that light. You've been cocooned in it since birth. Everyone has. So as you lie there beneath that imagined night sky, take a moment to imagine the world not as darkness sprinkled with stars, but as the afterglow of a once blinding universe, still stretching, still spreading, still traveling. This fog era might seem far away from your bed, but it's woven into everything you see. The galaxies you imagine overhead were shaped by that fog. The stars inside them formed because of those tiny fluctuations frozen into the glow. Even your atoms, your electrons, your protons, follow the same rules that were set during this foggy childhood of the cosmos. And once the fog cleared and the first light rushed outward, the universe revealed the blueprint inflation had left behind. A blueprint we're about to step into next. The era when space expanded faster than light could possibly keep up, stretching tiny fluctuations into the seeds of everything. Inflation isn't just a chapter. It's the story of how structure became possible at all. Keep that softness in your breath, and let the quiet around you hold steady, because now we're stepping into a part of the universe that isn't just hard to imagine. It's almost designed to overwhelm the human brain. We're going back before the fog, before the glow, before matter existed in any form you'd recognize. We're heading into the moment so brief, so compressed, so violently fast that even calling it a moment feels like an exaggeration. This is inflation, the universe's impossible sprint. And before you try to picture it, let me gently warn you, inflation doesn't care about your intuition. It doesn't care about what makes sense or what feels natural or what your high school science teacher told you. It's the universe behaving in a way that breaks every instinct we have about motion, speed, and growth. But that's okay. The point isn't to fully grasp it. The point is to let the scales sink in slowly, like letting warm water creep up your shoulders. Imagine everything you've ever known. Every galaxy, every star, every atom, every particle, compressed into something smaller than a proton. Not metaphorically smaller, literally smaller. All of existence wasn't just tight, it was subatomic. And then, suddenly, without warning, space itself began to stretch. Not expand like a balloon being inflated by a lung, not stretch like dough being pulled, but expand so fast that the best comparison is a tiny flick of time, a fraction of a second, where the entire observable universe ballooned out faster than light could ever hope to chase. Here's the thing, nothing inside the universe can travel faster than light. But space itself? It plays by different rules. Space can stretch faster than light can move across it, and during inflation, it did exactly that. Space wasn't just growing, it was erupting. Close your eyes for a moment and imagine the tiniest vibration, a quantum ripple, something smaller than anything you could ever see. Now picture that ripple being pulled, stretched, smeared across distances so huge that today they span light years. Inflation took the microscopic and painted it onto the sky. It took quantum noise and made it into the blueprint of the cosmos. Those tiny fluctuations, those little up and down blips, became the seeds of everything. Galaxy clusters, voids, the cosmic web, the shape of space itself. If inflation hadn't stretched quantum fuzz into cosmic structure, the universe today would look like a featureless fog. No stars, no planets, no you. Just endless sameness. But before that happened, the universe was a strange state of energy, a kind of unstable vacuum, like a ball balanced precariously on the tip of a hill. Inflation was the moment that ball rolled off and released its stored energy all at once, converting it into matter, radiation, and the heat that would eventually glow as the cosmic microwave background. But the roll wasn't smooth. It wasn't slow. It wasn't gentle. It was violent, exponential, a runaway process that took the universe from impossibly tiny to unimaginably vast in a sliver of time, smaller than anything you can compare it to. If you blink, you miss trillions of times more time than inflation took. Here comes the part that always settles over people like a soft weight. Inflation didn't just explain how big the universe is. It explained why it looks uniform in every direction. Without inflation, distant parts of the universe shouldn't match. They shouldn't have the same temperature. They shouldn't show the same patterns in the cosmic background. And yet they do. Inflation made that possible. It took a tiny, tightly connected region where everything could interact and stretched it so wide that billions of light years now lie between places that were once close enough to whisper to each other. That's why the cosmic microwave background looks so eerily smooth. Those regions were born next to each other. Inflation just yanked them apart. Take another slow breath. Let your shoulders drop. Because now, imagining this pre-light era, you're drifting through a universe that was expanding faster than any speed you've ever heard of. Faster than fast. Faster than metaphor. The numbers stop meaning anything. During inflation, the universe doubled in size dozens of times. If you doubled a grain of rice once per second, you'd have enough rice to fill a stadium in a minute. Inflation doubled the universe again and again in a time so short it almost doesn't fit in language. And with each doubling, the structure of space smoothed out. Curvature flattened. Differences were ironed out. The universe became uniform, balanced, and astonishingly consistent. And then, just as suddenly as it started, it stopped. That sounds simple, but imagine an explosion that starts and ends so quickly that if you blinked, the entire event would fit inside the blink with room to spare. Inflation ended by converting the energy that drove it into heat. Furious heat. Enough heat to fill the universe with a kind of primal fire. This transition is called reheating. And it's exactly what it sounds like. Space dumped its inflationary energy into particles, radiation, and raw material. The universe lit up from within. Not with stars, but with energy so intense that atoms couldn't exist yet. Reheating was the spark that prepared the universe for everything that came next. Stars, galaxies, the cosmic web, and eventually, after a chain of events longer than you can comfortably sit with in one breath, life. You're made of reheated cosmic leftovers. But we're not done with inflation, because the story isn't just about speed, it's about consequences. Inflation didn't just stretch our universe. It may have created others. Some models suggest inflation stops in patches, like bubbles forming in a pot of boiling water. Our universe would be one bubble. Others could exist, endlessly forming in regions where inflation never completely ended. Picture yourself floating in a vast cosmic ocean, dark, empty, calm. Then imagine bubbles forming endlessly across that ocean, each one expanding slowly internally while the ocean between them expands faster. The bubbles never meet. They never touch. Each bubble has its own physics, its own initial conditions, its own version of reality. That's one version of the multiverse, inflation's multiverse. Not fantasy, not fiction. A natural consequence of the equations, if inflation behaves the way some models suggest. Are those other bubbles real? Are they out there? We don't know. We might never know. They may be forever out of reach. But inflation opens the door to the possibility, gently and without drama, as if saying, look, the cosmos may be even bigger than you think. And by the time inflation ended, the universe was ready for the next chapter. The fog, the plasma, the cooling that led to atoms and the release of light. The universe took its first breath of order after a storm of impossible expansion. Right now, think about how far we've come. You started this journey lying in your bed, staring up at the imaginary night sky. Now you've drifted back to the beginning, to a moment when space blurred the line between physics and magic, when time barely had meaning, when distance exploded into existence, and when the seeds of galaxies were quantum ripples stretched across a newborn cosmos. And as you rest there, keeping your breath slow and your mind open, we're about to glide forward into the next mystery, the shape of space itself. Because inflation didn't just stretch the universe. It may have decided the geometry of everything, flat, smooth, and perhaps infinite. Let your breath settle again. Slow, steady, easy. Because now that inflation has finished its impossible sprint and the universe has cooled just enough to begin revealing itself, we're drifting into one of the strangest truths about reality. Something so ordinary sounding that people often overlook how unsettling it really is. The universe appears flat. Not flat like a sheet of paper. Not flat like a pancake floating in space. Flat in the sense of geometry. How lines behave, how angles add up, how large-scale space curves, or doesn't. And right now, as you lie there safely under the soft hum of your room, you're wrapped inside a cosmos whose geometry whispers something enormous. It whispers, there might be no edge at all. So let's ease into this. Imagine again that endless fog clearing. Imagine photons beginning their long journey. Imagine the universe expanding into something calm and orderly enough that light could finally travel in straight paths. And now, as we glide slowly forward, picture yourself sitting in a vast, empty plain that stretches in every direction. Look to the left. It extends. Look to the right. It extends. In front of you, endless. Behind you, endless. No curvature. No bending. No slopes. Just straightness. That is what flatness feels like on cosmic scales. But don't let the simplicity fool you. Flatness isn't normal. Flatness is weird. Because the universe doesn't just happen to be flat. The early universe could have curved inward like the surface of a sphere. It could have curved outward like the shape of a saddle. But instead it sits in this delicate balance where parallel lines stay parallel, where triangles behave exactly the way they did on your old geometry homework, and where the geometry of everything is so precise that if you stretch two laser beams across billions of light years, they would barely drift apart or converge. That precision is unnerving. Space is flat to within a tiny margin of error. So tiny that if the universe were even slightly more curved, we would see it clearly in the sky. The cosmic microwave background would look distorted. The distribution of galaxies would warp. Light would behave differently as it crossed billions of light years. But none of that happens. Everything lines up as if someone ironed the fabric of reality until it was smooth. Inflation explains this. It took whatever curvature existed, no matter how small, and stretched it beyond detection, like taking a balloon and inflating it so massively that the part you're sitting on feels flat. You don't feel the global curvature, even if it's technically there. That's the surprising thing. The universe might still be curved overall. It might still be finite, but inflation would have stretched it so much that the curvature becomes invisible to us. We could live inside a shape that loops back on itself without ever noticing. But for now, all measurements say it's flat. And flatness opens two possibilities, and both are enormous in their own way. The first possibility is that the universe is infinite. Not just very big, infinite. Endless space. No boundaries. No walls. No cosmic membrane sealing us in. Just more and more space in every direction, forever. But infinite space comes with unsettling implications. If matter is evenly distributed on large scales, then everything that can exist must exist somewhere, simply because in an infinite canvas, every pattern repeats eventually. Somewhere far beyond any light we could ever receive, there could be another arrangement of galaxies like ours, and another, and another. Not because of magic, but because infinity demands repetition. In an infinite space, probability doesn't just allow strange things, it guarantees them. But that's only one possibility. The second possibility is more subtle. The universe could be finite but unbounded, like the surface of the Earth. The Earth feels infinite if you just keep walking. You never find an edge. But eventually, if you kept going in a perfectly straight line, you'd loop back to where you started. Now imagine that concept in 3 dimensions. A universe that wraps around itself, forming a shape with no edge, no boundary, no outside. You could choose a direction and go straight ahead forever. You would never find a wall. You would never fall off. You would never hit a boundary. And yet, after an unthinkably long journey, you might reappear at the starting point without ever turning around. That's not science fiction. That's a valid cosmic topology, one that scientists take seriously. So why haven't we seen repeated patterns in the sky? Why doesn't the cosmic microwave background show matching regions, like reflections or duplications, implying that light has wrapped around space? People have looked hard, with precise measurements, over and over. And every time, the universe appears too big for its wrapping to matter. If space loops, it does so on a scale far larger than the observable universe. Meaning, the repeating pattern, if it exists, lies beyond the horizon, beyond what light has had time to show us. So from your bed, listening, you're effectively living inside something that feels infinite, even if it isn't. You're inside geometry that gently suggests there is no outside, no edge, no cosmic border. Just a smooth, flat expanse that inflation stretched into near-perfect uniformity. Now, settle your breath again, because here's where the beauty comes in. Flatness means the cosmos doesn't end in any dramatic way. There's no cosmic cliff, no wall, no dome, no bubble boundary. If the universe is flat and infinite, it simply continues quietly, smoothly, beyond what we can ever explore. And if it's flat but finite, then it still continues without interruption until one day, after distances so enormous they almost break imagination, you find yourself back where you began. Either way, the universe behaves like a space with no edge. And lying there beneath your imaginary night sky, this matters. Because the next time someone says, "What's beyond the universe?" the answer might secretly be, nothing needs to be beyond it. A shape can exist without an outside. A space can be complete within itself. The universe doesn't need a container. It is the container. Feel how calming that idea can be. There's no border waiting out there in the dark. No barrier. No end. Just a continuation of the same rules. The same smooth geometry. The same quiet vastness. But flatness leads to one more question. One you can almost feel forming in your chest. If the universe has no edge, then what lies beyond what we can see? Because flatness has nothing to do with visibility. The universe we can observe is only a piece, a bubble of sight defined by the age of light. Flatness only tells us how space behaves within that bubble. It doesn't tell us how far the rest of it stretches. It doesn't tell us whether the unobservable regions look like ours. It doesn't tell us whether the endless dark continues forever or transforms into something else, unknowable. And that's where we go next, beyond the light frontier, beyond the horizon that even future telescopes will never cross. The flat universe might have no edge, but we do. And the boundary isn't physical. It's made of light itself. Settle back again. Let the air move slowly in and out of your chest. Because where we're drifting now is delicate, stranger, softer, harder to hold in a single picture. We've talked about a flat universe, one without an obvious curve or edge. But flatness doesn't mean simple. Flatness doesn't mean empty. And it definitely doesn't mean the universe is shaped the way your instincts imagine. In fact, the universe might be hiding a shape so clever, so subtle, so perfectly disguised that you could travel through it forever and swear you were moving across a limitless plane, only to eventually arrive back exactly where you started. Not by looping around a planet, not by orbiting anything, not by turning, by walking or floating in a straight line. Forward, always forward, and you'd never sense the return. So as your breathing stays easy and your mind stays soft, we're going to explore the shapes that space could secretly have. Shapes that feel infinite but aren't. Shapes that bend without curving. Shapes that wrap without edges. Shapes that let you move forever without ever hitting anything like a wall. The first step is letting go of the picture frame version of the universe. Most people imagine space the way they imagine a room. Something with an inside and an outside. Something with walls. Something you could point to from afar, if only you could step back far enough. But space is not a room. There is no outside. There is no vantage point above it. There is no cosmic balcony where you could look down and see the universe like a snow globe. The universe does not sit in anything. It isn't floating in a bigger field. Space is the field. And once you accept that, even loosely, even with a half smile of, okay, I'll let that slide, the door opens to shapes that only exist because the universe doesn't need an outside to hold them. So imagine this, a flat universe that loops. Not curved like a sphere. Curved space would show its curvature. This is different. This is a topological trick. It's like a video game map where walking off the right edge brings you back on the left, except in 3 dimensions and without any glitchy seams. The simplest version of this is something mathematicians call a 3 torus. If that name feels intimidating, don't worry, we're not doing homework. All it means is a shape that loops around in 3 directions. You can imagine it like this. Take a cube, glue opposite faces together so that walking through one wall brings you in through the opposite wall, and then imagine the cube isn't sitting anywhere. It has no exterior. The universe is the cube's interior, endlessly looping on itself. Move forward forever, and eventually you return to the same location. Turn left forever, same thing. Turn upward, same thing. Not because you turn around, because space folds flawlessly. This shape is flat, perfectly flat, and yet finite. No boundaries, no edges, no ends. If that sounds too dreamy to be realistic, remember, the equations of general relativity allow it. Cosmologists actively test for it. And one of the biggest clues we have, if the universe were shaped like this, would be repeated patterns in the cosmic microwave background, like seeing the same set of stars printed in 2 different directions, or like hearing an echo of the early universe coming from 2 places at once. But so far, silence. No repeating circles. No duplicated patterns. No cosmic wallpaper that loops. If space loops, it loops on scales far larger than the portion we can observe. Our observable bubble might be too small to detect the wrapping. Imagine being an ant on a basketball. If you can't see far enough, the surface looks flat and infinite. You have no way of knowing it curves. That's us. Ants in a cosmic gymnasium, unable to see the far wall. But the torus isn't the only shape space could hide. There are dozens, hundreds of possible topologies that bend and twist and fold without requiring any curvature. Some look like twisted versions of a torus, where moving in one direction rotates you ever so slightly before re-entry. Some are more elaborate, with identifications that create paths you could travel 100 billion years without repeating, even though the space is technically finite. These shapes are so subtle that even if we lived in one, we might never notice. The universe could be playing a topological sleight of hand, making infinity feel like the default while quietly wrapping everything behind the scenes. And here's a soft, almost funny thought. You could be looking at light that left a galaxy on your left side of the sky, when that galaxy is actually the same one you'd see on your right, just reached by a path that wrapped around the universe. Imagine two windows in a hallway showing the same tree outside, and everyone arguing about why the trees look identical, unaware the hallway loops around one single backyard. But again, so far, no signs. Which means one of two things. Either the universe loops on a scale far larger than we can observe, or it doesn't loop at all. And if it doesn't loop, then flatness implies something more dramatic. Endlessness. A universe that goes on forever with no repetitions required. A universe so vast that even if you traveled in one direction for a quadrillion years, you would still be inside the same smooth, flat geometry, still seeing galaxies fade as you pass them, still moving deeper into regions no one has ever glimpsed. Take a slow breath at that. Not a panicked one, a soft one. Because whether the universe loops or not, the feeling it leaves is the same. The universe is bigger than your intuition knows how to handle. And that's okay. You are not built to hold infinity in your head. You are built to wonder about it. Topologies also remind us that what feels like the edge is just the edge of what light has reached. Not the edge of space itself. Not the limit of existence. Just the limit of visibility. Think of a foggy valley. You look out, and the world seems to end in a blur. But beyond that blur, the landscape continues exactly the same way. There's no cliff hidden in the fog, just more hillside. That's the universe. We're standing in the visible clearing, looking outward at a horizon that isn't a boundary, just a limit of sight. But topologies raise a deeper question. If the universe loops, then space contains itself. If the universe is infinite, then space contains everything. Either way, there is no outside. There's no cosmic shore, no wall to bump into, no final curtain you can peel back. And that leads us into something even stranger. The realization that beyond the shapes space might hide, beyond any wrapping or looping or subtle geometry, lies a region we cannot reach. A region permanently beyond visibility. Not because of shape, because of light, because of expansion, because of the simple fact that some regions, no matter how long we wait, will remain forever out of reach. Not just practically, but fundamentally. Keep breathing softly. Let your shoulders stay low, your jaw loose, your eyes half closed or fully closed if that feels better. Because now we're crossing a threshold, one of the deepest boundaries in all of cosmology. And the strange thing is, it's not a wall or a border or a fence. It's not made of matter or energy or anything you can touch. It is made entirely of light and the lack of it. We're stepping beyond the light frontier. Imagine again the observable universe, the sphere around you defined not by distance but by time. Roughly 46 billion light years in every direction. Not because the universe is that young, but because space has been stretching the whole time light has been traveling toward you. That boundary feels clean in your mind, like the edges of a map. But it isn't. It's not fixed. It's not solid. It's not a place you could point to. It's simply the farthest distance from which light has had enough time to reach you since the beginning of everything. And now comes the twist that always makes people go quiet. Beyond that sphere, beyond that shimmering horizon of visibility, the universe continues. Whether it stretches infinitely, loops subtly, or bends in ways you can't see, space doesn't stop where the light stops. That line isn't the edge of the universe. It's the edge of your access to it. To understand how fragile that access is, imagine you're floating in the middle of an immense, dark sea. The water extends in every direction, infinite and silent. You're holding a lantern that illuminates only the region immediately around you. Everything outside that glow is still there, unchanged, untouched, just unseen. The only difference is your lantern light reaches some places and not others. The universe is the same. Light is our lantern. The observable sphere is the glow. And beyond it lies everything else. Vast, cold, unreachable, but real. Now slowly let your breath fall into a rhythm as we stretch your mind outward. There are galaxies far beyond your horizon. Entire clusters. Walls of galaxies forming structures larger than imagination. They are out there. But the space between you and them is expanding so quickly that their light will never reach you. Not now. Not in 10 billion years, not ever. There's a whole invisible universe beyond your sight line. But here's the part that feels almost poetic. Some of the galaxies you can see are already lost to you. Their light from millions or billions of years ago is reaching your eyes right now. But any new light they emit, any future shine, will never get here. Those galaxies are already receding beyond the speed at which light can make progress. It's like hearing a friend calling to you from across a field while they walk away. You hear their last words reaching your ears long after they've gone beyond shouting distance. That's what many galaxies are doing. We see their final messages sent ages ago. But the communication has already ended. The connection has already broken. Their present selves are forever beyond our reach. So what does the light frontier look like? Surprisingly, nothing at all. No glow, no dome, no shimmer. It feels like the universe you see right now. Stars overhead, galaxies faint and small. That's it. The frontier isn't visible. It's defined by the speed of light and the speed of expansion. Two rules that quietly carve a limit into the sky without leaving a mark. Now imagine you're drifting near this invisible boundary. You're not outside the universe. There's no outside. You're simply at the edge of the part of the universe that can communicate with you. And beyond that boundary lies territory that might as well be another reality. Regions so far away that even if you traveled toward them at the speed of light, you would never make progress. The space between you and them expands faster than you could ever cross. It's like trying to swim upstream in a river where the current grows stronger the further you go until eventually the water carries you backward no matter how hard you swim. That's what the expansion of space does. It doesn't fling galaxies through the universe. It stretches the universe itself, pulling everything apart quietly, with no sound, no wind, no vibration. Just distance growing second by second. And somewhere beyond your observable bubble lies the permanently unobservable universe. Not temporarily hidden, not waiting to be discovered later with better telescopes. Permanently unreachable, beyond every possible future attempt to study it. That's why cosmologists sometimes call the visible universe a horizon, in the same way sailors on Earth see a horizon at sea. It looks like the world ends there, but you know it doesn't. You know the ocean continues. You just can't see beyond the curvature of the Earth. Except in cosmology, the curvature isn't the problem. The problem is the flow of space-time itself, moving faster than your signals can travel. Now breathe softly again, because this is the moment where your imagination and the actual physics start to blend. Somewhere out there, beyond the horizon, space may look just like ours. Same physics, same kinds of galaxies, same distribution of matter. Or it might not. Maybe it changes in subtle ways. Maybe it changes in dramatic ways. Maybe entire cosmic regions follow different histories, shaped by tiny early fluctuations that inflation stretched far beyond your reach. But you will never know, and that is not a failure. It's a boundary written into the universe by nature itself. This is where a quiet, almost philosophical truth settles over the story. There's more universe that you will never see than universe you ever can. Most of existence is hidden not by mystery, but by physics. But don't let that feel bleak. There's something quietly comforting about knowing you live inside a window that's only open for a limited time. A window that is wide right now, in this moment of cosmic history, but won't stay open forever. A window that lets you see relic light from the dawn of time. A window that future civilizations, trillions of years from now, will no longer have. You are alive during the only era when the universe is truly readable. And drifting just beyond your sight is a frontier that will forever remain dark. Not because it's empty, but because light cannot travel fast enough to outpace the expansion of space. If you could somehow step across that frontier, not in a spaceship because that's impossible, but by stepping outside the rules of physics, you would enter a region where galaxies race away endlessly, where cosmic structures form independently, where the universe has evolved along its own path, hidden from every eye that ever lived on Earth. You would see a cosmos that is real and full and vibrant, but one that no one here will ever glimpse, not even in theory. It's the universe's silent majority, the unseen, the unlit, the unreachable. But even that doesn't capture the strangest idea ahead, that beyond this frontier of unreachable galaxies, beyond the inflation-stretched regions we'll never observe, there may not just be more universe. There may be other universes, bubble regions, quantum branches, entire realities disconnected from ours not by distance, but by physics itself. Settle back into that same slow rhythm. In and out, the room is quiet, the air is gentle, and your mind is drifting right at the edge between curiosity and calm. Because now, we're stepping beyond even the unreachable regions of our own universe. Past the galaxies whose light will never reach us. Past the stretched-out structures inflation flung across unimaginable distances. We're stepping into the possibility that our universe, this entire cosmic bubble you've been floating through, is just one voice in a much larger choir. A chorus of universes. And I want you to take this slowly, not as a shock, not as a jump. Let it seep in the way dusk seeps into a quiet room. Because the multiverse isn't something we're adding for fun. It isn't a science fiction detour. It rises naturally from the physics you've already walked through. Remember inflation, that impossible runaway expansion that took the universe from subatomic to cosmic size? In many versions of the theory, inflation doesn't end everywhere at once. It ends in patches. Little islands where the inflationary field decays and space settles, forming bubble-like regions where matter, energy, and structure can emerge. Our universe, everything we see, is one of those patches, one bubble, but the inflationary space around it, that's still expanding, still stretching exponentially, still forming more bubbles, cosmic regions that never touch, never communicate, and never share light, because the space between them expands faster than any signal can cross. Picture boiling water. Bubbles rise, each its own tiny world, surrounded by more boiling water where more bubbles keep forming. Now zoom out until the boiling water stretches forever, with bubbles forming endlessly, all isolated from each other. That's eternal inflation. A multiverse created not by fantasy, not by imagination, but by the same physics that explains why our universe is flat, smooth, and full of structure. This idea wasn't invented to be dramatic. It fell out of the math like a natural consequence. So now picture yourself floating in a dark, endless sea, an ocean of inflating space. Every so often, a bubble forms and grows, like a faint lantern flicking on in the void. Inside each bubble, space unfolds. Physics settles. Matter forms. Galaxies ignite. Time begins. Not a single one of these bubbles can ever meet another. They're too far apart, too fast diverging, too disconnected by the expansion of space itself. You could travel forever in any direction and still never reach another universe. They might as well be existence running on entirely separate tracks. That's one version of the multiverse. But let your breath stay slow, because there are more. Now, imagine drifting closer to one of those bubbles, ours. Inside this bubble, quantum mechanics rules everything on small scales. You know quantum rules already. You live inside them every day. Particles behave like waves. Outcomes are probabilistic. Every measurement reduces possibilities into one reality. But one interpretation of quantum mechanics, the many worlds interpretation, says the wave function never collapses. Every possible outcome actually happens. Each possibility becomes its own branch of reality. Each branch evolves independently. None communicate. None cross. They exist side by side like ghost rails running parallel forever. This version of the multiverse isn't about bubbles separated by space. It's about branches separated by possibility. In one branch, a particle goes left. In another, it goes right. In one branch, a star forms. In another, it collapses. In one branch, you exist exactly as you do right now. In another, the world unfolded differently long before you were born. This doesn't mean endless copies of you exist in any cliché sense. These aren't clones with your personality. They're outcomes of quantum events that accumulated entirely new histories over billions of years. If branching happens continuously, and that's what many worlds suggests, then reality is constantly fanning out into a fractal of parallel histories. You'll never meet them. You'll never sense them. They are divided from you not by distance, but by decoherence, by physics itself. That's the second version of the multiverse. Now your breath should stay steady, because we're not done. String theory, another attempt to unify physics, predicts a landscape of possible universes, each with different shapes of extra dimensions, each with different physical constants. Some universes might expand too fast for atoms to form. Some might collapse instantly. Some might never allow stars. Only a very small fraction would have parameters gentle enough to support structure. If eternal inflation samples these possibilities, then each bubble universe could be a different realization of the string landscape, a different set of laws. Imagine universes where gravity is slightly stronger. Stars burn hotter and faster. Galaxies collapse early. Imagine universes where gravity is weaker. Stars can't ignite. The cosmos remains dark. Imagine universes where the charge of the electron is different. Chemistry fails. Imagine universes where dark energy is larger. Space expands too quickly for galaxies to ever form. Most universes would be silent, stillborn, empty, but a few, rare, precious few would expand just right, cool just right, form stars, planets, and chemistry just right, long enough for life to wonder where everything came from. And you're in one of those few. That's the third version of the multiverse. You don't have to believe any of these. The point is not belief. The point is understanding why physicists take them seriously. The multiverse isn't a wild idea thrown into the air because someone wanted more worlds. It's what happens when you follow the math of inflation, follow the implications of quantum mechanics, or follow the structures inside string theory. These ideas were not invented to explain each other. They emerged from different corners of physics and accidentally pointed toward the same possibility. Reality might be bigger than a single universe. Now slow your breath again. Let this settle. If other universes exist, they are completely unreachable, not hidden behind galaxies, not sitting at the edge of space, not waiting for a better telescope. They're sealed off entirely, either by the expansion of space or by the structure of quantum mechanics. No bridge exists, no tunnel, no portal, no trick. They are as separate from us as numbers are separate from colors. So then the question becomes, if we can never see them, why talk about them? Why consider them part of physics at all? The answer is subtle. Physicists don't accept the multiverse because it's comforting or exciting. They consider it because certain theories that explain what we can observe naturally predicted. Inflation explains the cosmic microwave background and structure of the universe, and inflation often predicts bubble universes. Quantum mechanics explains the behavior of particles flawlessly, and many worlds removes the need for wave function collapse. String theory tries to unify forces, and the equations allow countless stable configurations. The multiverse appears not because scientists chase more worlds, but because the attempt to understand this world sometimes demands more. And here's the whispering truth hidden under all of this. Even if other universes exist, you will never be less real. Your universe will never be less meaningful. You are not a copy. You are not small. You are not diluted. You are part of a cosmos rich enough to allow curiosity. You are living inside one bubble that has been unfolding for nearly 14 billion years. One timeline branching forward second by second. One set of stars strung across one strip of space, glowing softly in a universe that has just the right ingredients for minds to ask questions. And whether or not other universes are out there, the next question in our journey is this. If our universe might be one of many, how do scientists decide what counts as science at all? What makes a theory legitimate, and what makes it imagination? Where do you draw the line between inference and speculation? That's where we're gliding next, into the quiet debate at the boundary of knowledge. Take one more long, slow breath, the kind that loosens your chest without you even trying, and let yourself sink deeper into that calm, late-night headspace. Because now we're drifting into a part of the journey that isn't about galaxies or bubbles or cosmic fog. It's about something quieter, but no less vast. How we actually know anything at all. How science decides what belongs inside its circle and what sits just outside, waiting in the dark. You've traveled from the first light to inflation's impossible speed, through flatness, hidden topologies, and the haunting silence beyond the light frontier. You've glimpsed the possibility of other universes blooming like lanterns in a dark sea. And now comes the soft but serious question. How far can science reach before it stops being science? Where does evidence end and imagination begin? This is not a dramatic question. It doesn't come with lasers or wormholes. It's whispered, gentle, careful, by scientists who spend their lives staring into data, equations, and cosmic background maps. It's whispered because the edge of knowledge isn't a wall. It's a dimming of light, a fading of signals, a subtle shift between what you can measure directly and what you can only infer. And you're sitting right at that boundary in the quiet of your room, looking out across a universe where most of existence is permanently hidden from your view. So let's step right up to that line and see how science behaves there. Imagine a scientist looking into the night sky, measuring the faint ripples in the cosmic microwave background. Those ripples, the fingerprints of early fluctuations, fit beautifully with the predictions of inflation. Inflation tells us why the universe is flat, why the temperature is uniform, why structures have the size they do. And inflation also says, I might produce other bubble universes. I might keep expanding in patches forever. I might give rise to a multiverse. So what do you do with that? Do you accept everything inflation predicts, the visible and the invisible? Or do you treat the invisible parts as imagination? Some scientists say, if the theory works where we can test it, then we should take its full implications seriously. If inflation explains what we see and inflation predicts other universes, then other universes belong to the picture. Others say, no, a scientific idea has to be testable, even in principle. If you can never observe or falsify the existence of other universes, then it's not science. It might be philosophy, It might be logic, but it's not physics. These two positions aren't enemies. They're both trying to keep science honest, just in different ways. One side values predictive coherence. If a theory is good here, trust it everywhere it applies. The other values testability. If something can never be proven wrong, it shouldn't wear the badge of science. And you can almost feel how that tension echoes the unreachable regions of our own universe. We know the observable limit. We know what lies beyond must exist. We even know the laws that govern the part we can see. But we can never test whether the laws continue unchanged in regions beyond our light cone. Does that mean those regions don't belong in science? But does that mean science sometimes has to lean on inference? Here's where things soften, where the distinction becomes gentle rather than sharp. Science isn't just a list of facts. It's a method, a way of moving from observations to explanations. Sometimes that path is clear and direct, like watching the orbit of a planet. Sometimes it's indirect, like detecting black holes decades before imaging them. Sometimes it's profoundly indirect, like inferring atoms long before microscopes existed. You have never seen oxygen. You have never seen gravity. You have never seen an electron orbiting a nucleus. You have never seen space-time curve. You have never seen a wave function. But you see the effects. You see the patterns. You see the fingerprints. And those fingerprints are enough. Cosmology, in particular, is built on fingerprints. Ripples in the cosmic background. The distribution of galaxies. The faint tug of dark matter. The accelerated recession of distant supernovae. These aren't direct observations of the past or of unseen regions. They are signs, clues, shadows cast by deeper realities. So the question becomes, when a theory predicts something unobservable, but also explains many things that are observable, do you treat the invisible prediction as real? Some say yes. Some say no. Most say, it depends. What counts as science isn't determined by a single rule. It's defined by a community of thinkers asking the same question you're asking now, just with more equations and less pillow under their head. But let's draw the boundary gently, the way cosmologists actually experience it. If a theory can be tested in some of its predictions, and if those tests succeed, then the theory becomes scientifically credible, even if some of its implications remain unobservable. That's how we treat black holes. That's how we treated atoms for centuries. That's how we treat dark matter right now. And that's how many treat the multiverse, whether inflationary bubbles, quantum branches, or string landscapes. The multiverse is not accepted because it's exciting. It's accepted as a possibility because the theories that predict it also explain the sky you see. Still, caution is healthy. Some physicists keep the multiverse at arm's length, not rejecting it, but refusing to treat it as settled. They remind us that inference is powerful and limited. That no matter how compelling a model is, it still lives on the boundary between what we know and what we assume. And that boundary is shrinking. Not metaphorically, literally. Remember the dark energy you met earlier? The accelerating expansion? With each passing billion years, the observable universe grows smaller in content. More galaxies slip beyond reach. More cosmic information fades. Our ability to test theories becomes narrower over time. In the deep future of the universe, cosmology may no longer be possible at all. The evidence we use today, the cosmic background, the galaxy distributions, the expansion history, will vanish from view. Future civilizations might have no way of knowing the universe ever had a beginning. Science is ultimately bound by the light that reaches us. And so you're lying here under your imaginary night sky, listening to a gentle voice talk about unreachable regions and invisible universes, but everything we've discussed, every theory and every debate, is braided into the light that still arrives today, into the fingerprints written across the cosmic microwave background, into the geometry of space and the acceleration of expansion. Science doesn't end at the visible, but it also doesn't claim the unreachable without humility. It stands at the boundary line, steady, cautious, curious, using what can be seen to infer what cannot. And now that you understand where that line is drawn, we can move deeper into the future, deeper into the consequences of expansion, deeper into the quiet tragedy and beauty of what happens when the universe slowly pulls its own sky away from us. Because the next part of this journey is about disappearance, not of matter, but of visibility, not of galaxies, but of access. It's about the slow vanishing of the universe itself. Settle your body again. Let the air move in and out without effort, almost like you're floating. Because now, we're stepping into one of the most hauntingly beautiful parts of the entire story. Not something dramatic or violent, but something slow, quiet, and irreversible. Something happening right now, everywhere all at once, and so gently that you never feel a thing. The universe is disappearing, not ending, not collapsing, not shutting down, just slipping out of sight, one galaxy at a time. You already know the expansion of space is speeding up. Dark energy is stretching the fabric of the universe faster each moment. You already know light has limits, and the speed of expansion has none. And you already know that the observable universe isn't a fixed sphere. It's a shrinking window through which fewer and fewer cosmic objects remain visible over time. But now I want you to feel that, not in a panicked way, in a soft, cosmic way, like watching fog slowly reclaim a landscape at dusk. Close your eyes if you want and picture the night sky. Picture thousands of galaxies, each one a swirling island of stars. Picture them as lanterns hanging in a dark ocean, some bright, some faint, some so small they look like smudges. Now, imagine those lanterns are drifting outward, slowly at first, then faster still. Each galaxy is carried by the expansion of space itself, stretching the distance between you and it like ink dots on a balloon being blown up. And even though the dots themselves don't move, the balloon's surface pulls them apart. Now breathe slowly and imagine the space between you and the farthest galaxies expanding so fast that even the light they shine, light racing toward you at 300,000 kilometers per second, can't keep up. The light never arrives. Those galaxies are still shining. They still exist. But from your point of view, they fade into a distance they can no longer cross. Their final photons slip past, like the last words of someone walking away. After that, silence. This isn't imagination. It has already happened. There are galaxies whose last messages are right now, at this very moment, reaching Earth. The next photon they emit will fall behind, unable to overcome the expansion. We see them as they were billions of years ago, but their present selves lie beyond forever. Now extend that image. Picture billions of galaxies gently drifting past the horizon of visibility, like ships sailing into a fog that never clears. The night sky doesn't blink when they vanish. It doesn't dim suddenly. It just loses them, one by one, as if the universe were quietly cleaning up the edges. And that's the strange sadness, the strange beauty. The universe is growing wider while your access to it grows smaller. Here's a quieter detail. The observable universe gets bigger with time, but the number of galaxies inside it gets smaller. That's the paradox of an accelerating cosmos. Your cosmic map grows, but shows less. You live in the only era when the sky is full. In the far future, long after you're gone, long after Earth is gone, long after the Milky Way has merged with Andromeda into a single swollen galaxy, future observers, whoever or whatever they are, will look up and see nothing but their own local stars. No distant clusters, no cosmic web, no galaxies sprinkled across the horizon. Just a single island of stars surrounded by darkness. They will have no evidence the universe is expanding, no cosmic microwave background, no distant galaxies with redshifted light, no clues that the universe ever began in a hot, dense state, no fingerprints of inflation, no visible structure beyond their local group. From their perspective, the universe will look eternal and static. Cosmology, as you know it will be impossible. You are living in a cosmic golden age, a brief window where the early universe is still visible, where relic light still reaches you, where galaxies still shine inside your horizon. Right now, the universe is still readable, but the text is fading. Think about the cosmic microwave background you met earlier, the earliest light. It fills the sky in every direction, forming the universe's oldest photograph. But as the universe expands, that ancient light continues to stretch. Its wavelength becomes longer and longer, colder and colder. Eventually, it will reach wavelengths too large for any detector to sense. The universe's afterglow will dissolve into silence. The fog at the beginning of time will become fog once more, not because it grows thick again, but because it becomes invisible. It's almost poetic. The first light becomes the last thing to fade. Breathe slowly and let that settle. Now imagine you're drifting in the far future. Perhaps trillions of years from now. The stars around you are fewer. The cosmos is quieter. The galaxies beyond your local supercluster are gone from view. All the galaxies that once filled the sky, hundreds of billions, are now unreachable memories of a universe long faded. You look up, and instead of the grand cosmic web of the early universe, instead of the ocean of galaxies you might be imagining right now, you see a sky that's strangely simple, scattered stars, drifting quietly through a wider, darker void. Even if someone in that distant future had your intelligence, your curiosity, your desire to understand the universe, they couldn't. They wouldn't have the evidence. They'd never see the arc of expansion. They'd never detect the cosmic background. They'd never guess the universe had a beginning. They'd never know what was lost. But you do. Right now, lying here in the present universe, you live in a time where you can still see the past, still measure the cosmic background, still detect the fingerprints of structure, still map galaxies billions of light years away. You have the privilege of knowing the universe as a whole, not because you're special, but because you were born at the right cosmic moment. This awareness is fleeting, fragile, temporary. Cosmic knowledge has an expiration date, and so the sky is disappearing slowly, gently, quietly, not with a bang, but with a long exhale. The night sky you know today will someday seem impossibly rich to future beings. A breathtaking story written across the stars, gradually erased by distance and time. But this disappearing isn't sad once you settle into it. It reveals something beautiful. Every glimpse of the universe right now is precious because it's part of a cosmic window that will not stay open. You're looking through a fading doorway into the early universe itself. And as the universe keeps stretching, as more galaxies drift away, as light continues to fall behind expansion, we move into the next stage of our journey. What it means for a universe to fade from itself. What it means for the future sky to become empty. What it means for everything we know to eventually slip beyond light. Take another slow breath, deeper this time, and let it glide out of you like a soft tide pulling away from shore. You're entering one of the quietest, most surreal parts of a journey. Not the beginning of a universe, not the mystery of multiverses, not the violent fire of creation or the strange calm of cosmic fog. You're entering the far, far future. A future so distant, it makes the age of galaxies feel young. A future where the universe hasn't ended, but has gently, silently faded beyond recognition. This isn't a doomsday. It's not destruction. It's erosion. The slow, cosmic kind, where visibility shrinks until only a small island of stars remains, suspended in an ocean of expanding dark. So keep your breath soft as we drift forward through time, gliding through billions of years the way you glide through seconds right now. The universe around you is still expanding, still stretching space, still carrying galaxies farther apart, still pulling light into longer and longer wavelengths. And at some point, so far ahead that even the longest living stars haven't reached it yet, the universe enters a new era, the era of emptiness. Picture yourself standing on a quiet cosmic balcony, just you and the soft hum of expansion. Look out, and instead of a sky filled with distant galaxies, you see nothing. Not because those galaxies vanished, but because their light can no longer reach you. They exist beyond the horizon of forever. The night sky that seems so full today, packed with galaxies, clusters, shimmering structures, gradually dissolves. One galaxy disappears, then another, then 100, then 1,000,000, until only the galaxies gravitationally bound to your own remain. Everything else drifts beyond reach. The universe hasn't stopped expanding. It's just that your cosmic neighborhood is becoming the entire visible world. Imagine the local group, the Milky Way, Andromeda, a few dwarf galaxies, merging into a single giant elliptical galaxy. It's not chaotic or violent. It's slow, graceful, inevitable. Over trillions of years, the local stars swirl together like cream folding in a coffee. And when it's done, that one galaxy is all that remains visible. No cosmic web, no grand structure, no map of the universe. Just one immense island of stars floating alone in an ever-darkening sea. Cosmic loneliness becomes the default. Now breathe slowly and let your imagination soften everything. The cosmic microwave background, the universe's oldest light, is still out there, but stretched so thin that its wavelength is now the size of planets, then stars, then galaxies. Eventually it becomes so long, so faint, so dilute that no instrument in any era can detect it. The afterglow of the universe's birth fades into silence, and with it, the last visible connection to the early universe disappears. That relic light, the one that holds the pattern of tiny fluctuations, the fingerprints of inflation, the blueprint of structure, becomes undetectable. Lost not because it ended, but because it stretched itself into invisibility. Now imagine a future being, human or not, standing beneath the night sky trillions of years from now. They see only the stars within their own giant galaxy. They have no access to the cosmic background, no evidence of expansion, no distant galaxies to measure, no redshifts, no large-scale structure, no hint that the universe ever had a beginning. For them, the cosmos looks small, local, eternal. The grand, expanding universe you know today will feel like a myth. They might conclude that their galaxy is the entire universe. They might conclude that the universe has always existed, static and unchanging. They might construct physics without cosmology because the data to support it is gone. The universe hasn't ended, but story has, or at least the readable version of it has. This is the part where the fading becomes gentle, almost intimate, because the universe isn't collapsing. It isn't rushing toward doom. It's more like a campfire that gradually dims over billions of years until only embers remain. The heat is still there, but the glow is too faint to guide anyone. Eventually, even stars stop forming. Gas clouds grow thin, unable to collapse into new suns. The stars already shining live their lives and die, one by one, until only faint red dwarfs remain. They burn slowly, so slowly that their lifetimes stretch trillions of years, but even they eventually wink out. What remains is darkness studded with the faintest, coldest remnants of stars. Black dwarfs, stellar corpses that no longer shine. Brown dwarfs, failed stars, rogue planets, worlds drifting forever in the dark. The universe becomes a night with no dawn. But this isn't tragic. There's something peaceful in it, because the universe isn't fighting anything. It isn't collapsing inward or ripping itself apart. It's simply continuing along the trajectory set by dark energy. Expansion that pushes everything away from everything else until space becomes too vast for light to illuminate. This is a calm end, a quiet fade, a slow vanishing of visibility. But there's another layer, a deeper one. As the universe expands and cools, As galaxies vanish from sight, as stars burn out, something else happens. The universe forgets itself. Not because memory exists physically, but because the clues of the past are stretched beyond reach. The evidence that the universe had a beginning is erased. The tools you have now, cosmic background maps, galaxy surveys, redshift charts, become impossible to obtain. The universe erases the footprints of its own origin simply by expanding. And that's where the beauty hides. You, right now, lying here listening to this soft flow of words, are living in a cosmic moment that will never happen again. You exist in an era when the universe is young enough to be understood, old enough to be structured, and readable enough to reveal its history. You are alive during the period when the cosmos is transparent, when the first light still reaches you, when galaxies still shine inside your horizon, when cosmology is possible at all. You are one of the last generations in cosmic time who can know where the universe came from. The far future will have stars. It will have planets. It may have life, but it will not have cosmology. It will not have the big picture. And that makes your moment special, not in a mystical way, but in a cosmic one. You exist in a brief window where the universe has revealed itself, a window that won't stay open. Now, let your breath deepen again, because we're moving to the final part of this journey. Not an end, but a reflection. Not a conclusion, but a resting place. Because if the universe is fading from sight, and if most of existence is already beyond visibility, then the question becomes something softer. How do you hold wonder? In a universe mostly unseen? Stay exactly as you are. Don't change your breathing. Don't adjust your posture unless you want to. Just let your body settle into that warm, effortless heaviness. Because this final step of the journey isn't about physics anymore. Not really. It's about what all of this means when you pull the camera back, when the facts soften, and when your mind finally arrives at the horizon of thought. You've traveled across the universe tonight, from the clearing of the cosmic fog, to inflation's impossible sprint, to flatness and hidden topologies, to the fading of galaxies and the stretching of ancient light. And now, you're resting in a truth so immense that it almost feels like silence. Most of the universe is invisible. Most of it will always be invisible. And yet your place inside it is real, grounded, and meaningful. So let's drift into that gently. Imagine you're floating in space, not in a sci-fi way, but in a quiet, meditative stillness. No spacecraft, no helmet, just you as a thought, suspended in the dark. All around you, the universe expands softly, calmly. No war, no shake, just a slow, continuous stretching like breath. Galaxies shine in the distance, each one a story. Some are moving away, some are already gone from reach. Some are fading into wavelengths too long to ever be seen again. But from where you drift, their light still touches you, a whisper from a past they can't return to. And the question rises softly, like a ripple on still water. If most of the universe can never be seen, what does that mean for your place in it? The answer isn't depressing. It isn't lonely. It's something gentler. It means the universe is bigger than your worries, bigger than your timelines, bigger than every fear that ever kept you awake at night. If the universe can hold galaxies that drift into permanent darkness, if it can create structures so vast that light itself gives up trying to cross them, if it can stretch space faster than photons can move, then the things you're carrying, your stresses, your mistakes, your what-ifs, they are tiny compared to the canvas you rest within. Not tiny in a dismissive way, tiny in a liberating way. You don't have to hold everything. You don't have to control everything. You don't have to understand everything. Even the universe doesn't reveal everything at once. Now imagine lying back inside that cosmic sea. Behind you is the time before light, the fog, the fire, the roar of recombination. Ahead of you is the fading universe, stars cooling, galaxies drifting, existence becoming quieter. And here you are in the middle, at the perfect moment, the tiny sliver of cosmic time, where the universe can actually be known. You're living at the peak of cosmic visibility. Before you, the universe was too hot and too dense to be seen. After you, the universe will be too spread out to be seen. Right now, this era is the only era where the cosmos reveals itself. And that makes your existence extraordinary, no matter who you are, no matter what your life looks like from day to day. You're the product of a universe that stretched, cooled, clumped, collapsed, ignited, expanded, and evolved. Not just to create stars or galaxies, but to create observers. Creatures who can look at the sky and want to understand it. Who can sit under the night air and wonder what lies beyond what they can see. Who can drift off to sleep to the sound of cosmic history. Now breathe slow and soft. Because even if most of the universe is unreachable, even if entire regions are forever hidden behind the speed of light and the pull of expansion, that doesn't diminish your connection to it. You're not outside the universe looking in. You are not a spectator. You are part of the very fabric that's been unfolding since the beginning. Your atoms were forged in stars that lived and died long before the Earth existed. Your body holds hydrogen that formed in the first 3 minutes of the universe. The calcium in your bones was cooked in ancient supernovae. The iron in your blood comes from the cores of collapsing stars. You're literally made of cosmic history. And when the universe fades slowly from itself, when galaxies drift and light stretches and the cosmic background dissolves, your atoms will still belong to that story. Wonder doesn't disappear when visibility does. Meaning doesn't fade when light fades. The universe doesn't need to be fully seen to be deeply felt. And the remarkable truth is, you live in a moment where the cosmos still speaks, where the earliest light still bathes the sky, where the structure of the universe is still visible in every direction, where the grand story of existence can still be read. You're here for that moment. You get to witness it, and that is beautiful. Now the journey is complete. Not because the universe ends, but because you've reached the place where the visible fades into the unseen and where questions become softer than answers. All that's left now is rest. Let the room around you soften. Let the edges of things blur a little. Your breath, still slow, still easy, settles into the background like a quiet tide. There's no more to understand tonight, no more to explore, no more distance to travel. The universe can wait. Everything can wait. Picture yourself lying in a calm, wide space. Not physical, not literal, but a soft inner landscape where nothing asks anything of you. Above you, the universe stretches out, not as something to analyze, but as a gentle presence. All those galaxies, all those stars, all those unreachable horizons, they're not demanding your attention. They're simply there, like distant lanterns glowing in the dark. The expansion of the universe, the fading of the sky, the silent drift of galaxies. None of it requires effort from you. None of it presses against your mind. It all moves slowly, quietly, endlessly, without needing your control. Let that feeling seep through your chest. The universe carries itself. You don't have to carry everything. Let your thoughts drift like small boats on calm water. If one floats by, let it pass. There's no need to follow it. No need to push it away. Just let the motion slow, nearly to stillness. Your body is heavy in the good way, supported, grounded, safe. The air around you is soft. The dark is gentle. And you, lying there, are part of a universe that is vast enough to hold all your questions and calm enough to let you sleep. As the last traces of the day fade, let your breathing grow slower, softer, deeper, until your whole body feels like it's dissolving into rest. Good night, traveler, and sweet dreams.